Today, we're going to explore the fascinating journey of how palm oil is made from the ripe fruits of towering palm trees all the way to the refined oil bottled and ready for use. Palm oil is one of the most widely used vegetable oils in the world, present in everything from cooking oil and margarine to soaps, cosmetics, and even biofuels. The process behind its production is both intricate and impressive, combining manual labor, agricultural knowledge, and powerful industrial machinery. Palm trees thrive in tropical regions and can yield fruit for up to 25 to 30 years. Each mature palm tree produces approximately 16 to 20 kilograms of fruit per year. Globally, that adds up to over 300 billion pounds of palm fruit annually. Harvesting this fruit is the first step, because palm trees often grow up to 20 meters tall. Workers use long-handled poles with sharp blades to cut down the heavy fruit bunches. This job requires skill, precision, and stamina, especially under the hot sun. In flatter terrain or in areas with high volume production, machinery like excavators and shovels are used to speed up the harvesting process and reduce the burden on human workers. However, in remote or marshy plantation areas where heavy machinery can't be used, workers rely on traditional hand tools to gather fruit. Once enough fruit has been collected, it is loaded into large trucks, often with the help of excavators, and transported directly to the processing factory. Speed is crucial at this stage, as delays can cause the fruits to ferment, which lowers oil quality. Ideally, the fruits are processed within 24 hours of harvesting at the factory. The trucks unload the palm fruit bunches on the concrete platforms. With the help of front loaders, the bunches are pushed into collection areas, then loaded onto conveyor belts which carry them deeper into the factory. The first major stage of processing is sterilization. Here, the fruit bunches are transferred into massive pressurized steam chambers, where they are sterilized for 60 to 90 minutes. This high-temperature steaming kills bacteria, loosens the fruits from their bunches, softens the flesh, and halts enzyme activity that could spoil the oil. Following sterilization, the softened fruit bunches are transferred into a machine known as a stripper or thresher. This rotating drum separates the empty bunches from the individual fruitlets. The empty bunches are either discarded or recycled as compost or fuel. The loose fruits, which now contain the oil-rich mesocarb, are then directed into a digester machine. In the digester, the fruits are mashed with the application of heat and mechanical stirring. This step breaks down the oil cells and prepares the fruit pulp for pressing. Next, the hot pulp is fed into pressing machines, typically hydraulic or screw presses, which extract crude palm oil by squeezing the pulp under high pressure. At this point, two products emerge: crude palm oil, which flows as a thick, reddish liquid, and fibrous cake, composed of crushed fruit fibers and shells. The oil is collected in a reception tank, but it's still in an unrefined state and contains impurities such as water, plant particles, and sludge. To purify the oil, it first goes into clarifier tanks where gravity separates the oil from the heavier solids and water. The oil rises to the top while debris sinks. This clarified oil is then passed through a purifier machine, which uses centrifugation or filtration to remove even finer impurities. The result is golden clean palm oil that is ready to be cooled, filtered one last time, and bottled for sale. Inside every palm fruit is a hard seed called the palm kernel. After the initial oil extraction, the leftover nut is processed in a separate line to extract palm kernel oil. This oil has different properties and is widely used in cosmetics, soap production, and other non-edible goods. C. The process of turning palm fruits into palm oil involves a combination of traditional harvesting methods, advanced industrial machinery, and continuous innovation. From the fields where fruit is handpicked or machine harvested, to the factories where it's sterilized, digested, pressed, purified, And bottled palm oil production is a complex yet well-organized system. The next time you see a bottle of palm oil on the store shelf or use a product that contains it, remember the incredible journey it took. Kellogg sells over 2 billion Pop-Tarts every year, making it one of the most popular breakfast snacks in the world. That's enough to stack them to the moon and back, and still have enough left to survive a road trip with your kids. But have you ever wondered how a Pop-Tart is actually made in a factory? What goes on behind the scenes to create that shiny foil-wrapped square of nostalgia, sugar, and engineering genius? Let's take a journey through the process that transforms basic ingredients into an American breakfast icon, a tale of invention, competition, precise automation, and frosting resilience. Our story begins in the 1960s, an era when America was obsessed with convenience and novelty. People were racing to the moon, grooving to the Beatles, and apparently losing patience with eggs and bacon. Enter the battle for the toaster pastry, a tale as sweet and surprisingly cutthroat as the product itself. It started with Post, the cereal company behind grape nuts, a food that tastes like it was designed as punishment. They had a radical new idea, a fruit-filled pastry that could survive on a shelf for months, sealed in foil and ready to pop into a toaster. They named it Country Squares, because nothing says future of food like a name that sounds like a line dance for wheat. Pop-Tarts launched in 1964 with 4 humble flavors: strawberry, blueberry, apple currant, and brown sugar cinnamon. They were an instant hit. Breakfast would never be the same. Here's the twist: early Pop-Tarts didn't have frosting. Why? Because the frosting couldn't survive the heat of a toaster. It would either melt into goo or start smoking like a chemistry experiment gone wrong. So for the first few years, Pop-Tarts were naked, just a pastry shell with fruit inside. And still, people adored them. Then, in 1967, Kellogg's engineers cracked the code. They created a heat-resistant frosting that could survive the toaster without turning your kitchen into a smokehouse. The Frosted Pop-Tart was born, and it was a game-changer. It all begins with the dough. The basic recipe includes enriched wheat flour, water, sugar, salt, and fat, usually a combination of palm oil and vegetable shortening. These ingredients are loaded into industrial mixers machines, the size of a small SUV, and blended into a pliable, slightly elastic dough. Timing and temperature are everything. Overmix the dough and it gets tough. Undermix it and it can't hold its shape during baking. Once just right, the dough is portioned and sent to a giant sheeter, a machine with rollers as thick as tree trunks that flattens it to a precise 2 millimeters thickness. Meanwhile, in another part of the factory, the fillings are being prepared. Whether it's strawberry, chocolate fudge, or wild berry, each filling begins with a base of fruit puree or cocoa, sugar, corn syrup, and thickeners like pectin or modified cornstarch. This mixture is heated gently in massive kettles until it becomes a thick, glossy paste. The filling is then piped onto the dough in exact amounts, using nozzles so precise they can measure to the milligram. Each Pop-Tart gets a perfect squirt of fruity or chocolatey goodness. Then, another sheet of dough is gently placed on top, like a blanket over a sugar-filled bed. Next comes the crimping machine, which stamps down around the edges to form the iconic rectangle with sealed edges. Small steam vents are poked into the top to prevent puffing or explosions during baking. The resulting sheet of Pop-Tarts is then cut into individual units, and the trimmings are recycled into new dough. Then comes the tunnel oven, a massive baking chamber as long as a basketball court, where the pastries move on a conveyor belt through temperatures as high as 500 degrees Fahrenheit. As they bake, the dough firms, the filling thickens, and the edges turn a delicious golden brown. Sensors monitor heat, humidity, and even color to ensure consistency. Once baked, They're cooled before heading to the frosting station. Here, Pop-Tarts are coated with frosting made from powdered sugar, corn syrup, and stabilizers. The mixture is warmed to the perfect temperature and applied in smooth, even ribbons. For varieties with sprinkles, the pastries pass under machines that shower them with colorful sugar bits while the frosting is still wet. Timing is everything. Then it's on to quality control. High-speed cameras with an eye algorithm scan for imperfections, crooked frosting, cracked edges, missing filling. Finally, each Pop-Tart is paired with a twin and sealed in the iconic foil pouch. These pouches are nitrogen flushed to remove oxygen, keeping the product fresh for months. They're then boxed, labeled, and shipped off to supermarkets, vending machines, and pantries around the globe. The next time you tear open a silver pouch and take that first bite of warm, gooey center surrounded by sweet crust and frosting, remember, behind that simple treat is a story of industrial brilliance, cutthroat competition, and cultural absurdity. Pop-Tarts aren't just breakfast. They're a crispy, sugary time machine.
If you enjoy this video, make sure to like and subscribe for more updates. Share your thoughts in the comment section down below.